Hi everyone! Today, we're going to explore a common pattern you might see in Blazor WebAssembly applications: await task delay 1. It looks a bit odd, delaying for just 1 millisecond. But in Blazor WASM, it serves a very specific and important purpose. Let's dive in and understand why developers use it. First, we need to remember how Blazor WebAssembly works. It runs directly in your browser. Like most browser-based code, it operates on a single thread. This means all your application logic, user interface updates, and browser events share that one thread. If your code performs a long-running operation synchronously, it monopolizes this single thread. The immediate consequence is a frozen user interface. Your buttons won't respond, loading spinners will stop animating, and the entire page becomes unresponsive until your operation completes. This is because the browser's rendering engine and event loop cannot process their tasks while your code is actively running and blocking the thread. This is where await task delay 1 comes into play. When you await a task, you are essentially telling your code to pause at that point. Control is then yielded back to the calling context, which in Blazor WASM is the browser's main thread. By using task delay 1, you are requesting a minimal delay. This tiny pause, often less than a millisecond in actual execution, gives the browser's event loop a crucial window of opportunity. During this window, the browser can process pending UI updates, handle user input, and redraw the screen. Consider a scenario. You click a button to start a complex calculation. You want to display a loading message immediately. If you set the loading message and then run your heavy calculation without await task delay 1, the loading message might not appear until after the calculation is finished. The UI was blocked. By inserting await task delay 1, right after you set the loading message and before the heavy work begins, you allow Blazor to render that message. The UI gets a chance to update, making your application feel much more responsive to the user. It's like taking a tiny breath in your code to let the UI catch up. It's important to understand that await task delay 1 is not a magical performance enhancer for your CPU-bound tasks. It doesn't make your heavy computations run faster. Instead, it's a mechanism to unblock the UI thread temporarily. It breaks up a potentially long-running synchronous block of code into smaller chunks, allowing the browser to refresh the UI between those chunks. While it's often a useful workaround for ensuring UI responsiveness, especially when you're manually forcing a UI update with state has changed, it's generally best practice to ensure that truly long-running operations are handled asynchronously from the start. For very intensive computations, exploring web workers might be a more robust solution, but for immediate UI feedback in Blazor WASM, await task delay 1 is a simple and effective trick. Thank you for watching and learning about this interesting Blazor WebAssembly technique. If you found this explanation helpful, please give this video a thumbs up. And don't forget to subscribe for more Blazor tips, tricks, and deep dives.